This is activity 2.4 by Team 4. My name is Jaime, and these are the connections. Here we have our STM connected to the computer. Here we have some communication with the edge bridge, and here we have the plus and negative of the encoder, additionally to the encoder A and B, which are connected to the STM. The power sources are connected to the respective channels. And here for the motor we need more voltage, so we just make the grounds common right here and we feed the motor.
No, rápido. El input. Well, I'm Alejandro, and I'm going to explain the IOC configuration, the IOC file related to the configuration in the CubeID. We just use these 4 pins, which the main ones for this practice is the PC0, which is the external interrupt mode with falling edge trigger detection. It has a pull-up in the. It is configured in a pull-up way, and it's in the encoder A. The encoder B is not in the interrupt; it's in input mode, but it is used to detect if it is on or off to detect the direction of the motor. This one was default, and we don't use it. Then these 2 pins are directly connected to the H bridge to control the motor where clockwise or counterclockwise. Finally, the other configured pin is used in IDC for the potentiometer.
Here we're using, hello, my name is Luis Carlos Ramos, and in the code we're using the same basic structure of the activity 2.2, where we change directions depending on the value that we read of the potentiometer. We have the EPO pins, but the main change was done in the void function for the interruption. In this interruption, we are here. Here in the interruption, we are checking what direction the pin is by what direction is the motor rotating, depending on if the pin of the encoder B is on or off, and then we toggle that position on and off, and that changes the value of the long variable of position, the long variable position that we declare here. Then we declare another unit that it's the meter unit, and that value we are then translating into units of measurement, which is 20 meters, which is in meters. The ratio of our encoder is 12 ticks per revolution, and we have an encoder of 20.4 reduction on gear. So that gives us a ratio of around 240 ticks per revolution, and since our tire is 88 millimeters in diameter, then we multiply that by 3.14, and we get the meters move of our wheel.
Hello, my name is Justino Rodriguez, and I'm going to show the demonstration of what is going on here. In the first case, just to resume, the program it's coded in a way that when detecting a falling edge, we have the interruption occur, and said interruption is going to cause a change in the position variable that we have here. Said position variable is going to change depending on whether the encoder pin detects it's counterclockwise or clockwise, meaning that the rotation is going to increase or decrease the amount in the position variable. For example, here, as you can see, I'm going to rotate it by hand in one direction, and we can see the value increasing. When I stop, the value stops, and then in the contrary manner, the value decreases, which showcases that the program is well coded. Now, just to showcase what we did in the previous practice as well, I'm going to turn on this. We can see the value increasing. in set direction, and I'm going to change it with a potentiometer. Now it stops, and now it decreases. So yeah, that's pretty much it. Thanks.
Yeah.
Hello, my name is Luis Carlos, and this is a small appendix to the activity 2.4. We can see here we have a certain position in the debugger, and we can see that when pushing the blue button, the value of the position goes directly to 0, and we achieve that with a small function insertion in the interrupt function, where we check which pin is the one that is that had the interrupt signal, and then we make a small debouncer without using delays, because we need to check on time, and then we change the position of the value of position, and that resets the value to 0. And that's everything. Thank you.